Hey guys, sorry we have to do a lesson today. It'll be, relatively short. I just have to keep you on track with my other class and just keep us on track to finish the curriculum. And if we never meet on a Wednesday, which is almost what happens with period 4, we won't. So anyway, today we're going to talk about domain and range restrictions. We did it a little bit yesterday, but I want to just go over basically how to find the domain and range when there is a restriction. So there's 3 times that you would have a restriction on the domain. So basically, if you have a function and it doesn't have a denominator and it doesn't have a radical, there is no restriction. The domain will be all real numbers. But if there is a denominator, it can't equal 0. So what you do is you set the denominator equal to 0 and solve for the values that make it 0. And then whatever you get, those are the numbers that can't be in the domain. So the domain is everything but those numbers. And we'll do an example of all of these, of course. Okay, the next thing that can happen is if there's a square root. If there's a square root, you take what's under the square root, the radicand, and you set it greater than 0. Because the square root can't be negative, it can be greater than or equal to 0, and solve. And then that is the domain. So I'll show you an example of that, of course, also. And then the third thing that can happen, if there's a square root and it's in the denominator, so of course that looks like, a square root underneath. You would then set the radicand that's in the denominator just greater than 0 and solve, and then that would be the domain. So the ones with the radicals are going to have a domain that's, it's going to be an inequality, and you're going to write it as an interval. But the ones that just have a denominator with no radical, the domain is going to be almost every number. It's just going to take out a number or two that make the denominator 0, depending if the denominator is quadratic or not. So here's examples. So this would be one that would have no restrictions. Okay, this doesn't have a denominator, it doesn't have a radical. So the domain would be all real numbers, which means negative to positive infinity. There's no restriction. Any number can be plugged in for x. Okay, the next thing that could happen would be if you have a denominator. Okay, most numbers you could plug in for x, but denominator can't be 0. So you can just take the denominator, set it equal to 0. I'm actually going to put a not equal to because this is the number that x can't be. X can't be 1, but it could be anything else. So what's the domain? It's all numbers except 1, which is negative infinity to 1, union with 1 to infinity. Because if you look at it on a number line, we're talking all numbers, but that has an open circle. Everything to the left, everything to the right. Okay, then an example of a radical would be something like f of x equals the square root of x plus 6. Well, a lot of things will work, but anything that makes this negative will not work. So you take what's under the radical, set it greater than or equal to 0, and solve. This is actually the domain. All numbers greater than or equal to negative 6. Negative 6 is fine because it makes it 0, and anything above it. So as an interval, you would do negative 6 to infinity. Okay, let's do a more complicated radical. F of x equals the square root of x squared minus 121. Okay, now this is a quadratic, so when we set this greater than or equal to 0, we have to factor it. And when we do a quadratic inequality, we change it to an equal sign, we get the two roots, and then we figure out where the actual solution is. Remember this from a couple of units back. So these would be included because they would make it 0. But then you have to decide, is it in between or is it left and right? So you can plug a number in like 0 for x, and you would see that 0 doesn't work. Negative 121 is not greater than or equal to 0, which means the domain is actually to the left and right of these. So the domain would be negative infinity to negative 11 inclusive, unioned with 11 to infinity. Okay, if you have a quadratic inequality like this, you have to check a number in between, like 0, into here. And since 0 doesn't work, negative 121 greater than or equal to 0, no. That means that you don't shade there. That's why it's the two endpoints. So that domain's a little more complicated. And then, of course, the last thing that can happen is when you get a radical in the denominator. Now, the numerator doesn't matter. So the numerator could be a number, it could be an x, it doesn't matter. But once you have a radical in the denominator, now you got to worry about it not only being positive, but it also can't equal 0. So you would do 5x plus 20 is just greater than 0, no greater than or equal to, because it can't equal 0. And then you could solve that inequality. Oh, that's a greater than. Divide by 5, x would be greater than negative 4, so the domain would be negative 4 to infinity. All right, so normally I would do a lot more examples, but because you weren't even supposed to have class today, I'm just going to do those, and I'm going to give you a homework on this. If you have any questions tomorrow, I can answer them if you have any trouble with any of this. But basically, it's just the 3 rules. Denominator can't be 0, square roots can't be negative, a square root in the denominator can't be 0, and it can't be negative. All right, hope everyone understands and have a